So David, if you somehow see this video, we have changed the homework assignment to picking 6 or more out of those, and the point behind this is because tomorrow we're going to start your closure. There's no reason. I couldn't make an argument for slowing down like we had said we wanted to. I really couldn't, because there's no way that today's lesson, what I have planned, merging the two lessons, will even take more than a half hour. Guarantee it to you. So, let's talk trig. Now, some of this we're going to skip over because we're already smarter than this because, yeah, I overteach and you guys overlearn. So, when we talk about the tangent ratio, right, we decided yesterday, or not decided, we figured out or clarified or whatever, what is the tangent ratio actually giving us, Liang? The slope. So, since we know the tangent ratio when we plug in the degrees of the angle, or radians, if we understood that, but we don't yet, give us the slope. Nope. Go back. Then in situations like this, we're able to inverse that process, right? Use the inverse of tangent and figure out the angle. So remember that yesterday we talked about that second tangent button on our calculator? So now if we're trying to solve for these unknown situations, I don't know why I decided to say words awkwardly. Go ahead and tackle those 3 problems. Bet you we can do it in under 3 minutes.
I heard you say under a minute, and I'm like,
oh, you want to do under a minute?
No.
Okay.
No.
And go.
No. Under a second. No.
Go. You have 1 minute to do it, and then I'll see if I can do it in 1 minute.
No.
And I'll even write all of the work.
Oh, wait, so we're trying...
45 seconds.
No, not a minute. It's not so...
Try to find anything unknown. So that's in degrees. That's a 72 degrees. So triangle angle sum theorem lets us get the slope angle we're looking for, or we could just look at rise and run differently. Now, since the thetas in there are thetas, we want to figure them out. Yeah. But if I instead wanted to use the 79, I could just say tangent of 79 equals rise over run 12 over W.
Oh, well.
Or
I did.
We can say the tangent of 11 equals W over 12. Now this will actually be easier to solve because the unknown is on the top. Right? So we can just do 12 tangent of 11. And we know it should be less than 12 because the angle is less than 45. What'd you get, Sammy?
For A?
Yep.
About 2.3.
About 2.3? Anyone able to verify?
It's 2.33 and then a bunch of numbers. Yeah.
Now here, if I do rise over run using my 68, my variable ends up on bottom. So I'm actually going to do tangent of 22.
And Z over 8.
So it's all about being able to kind of, in your head, manipulate that. So we can just do 8 tangent of 22. If I want to make my life easy over here, do I use 18 or 72? 18, right? If we flip this and think about rise over run, x over 15, we want to use the 18. So what did our z turn into here? Should be less than 8.
It's 3.23. Well, yeah.
And our x down here,
I don't know that
5 tangent 18, 4.87. Any questions on using our technology to do this instead of just using a reference sheet?
I'm so glad we have calculators.
So it's just you always want the unknown variable to be the y.
Oh, it doesn't matter.
It's
So
easier.
it's easier. Yeah, the other way, let's say we go to solve this, you just have to train your brain to say, I can switch places. In a proportion, there's the means extremes theorem that says when I cross multiply and then divide out, these can actually essentially swap places. Because I get w times tangent of 79, and then I divide by tangent of 79, and I end up with
it'd be
12.
yeah,
So
12.
w, and you can go check your work this way, would be 12 divided by tangent of 79. And that should come out to still give you that 2.33, whatever. Make sense? Easier. Not right, wrong, just easier. So, what we just realized that we don't need to do, or this is why I'm saying we're able to merge these lessons and not like waste our time, is no matter what the triangle looks like, right? Like we learned in Ender's Game, there is no up in space. That's one of my favorite lines from like a kid's movie ever, because like I literally had this moment of like, yeah, he's right. Like up is made up. Made up. Up is perspective. In geometry, there's no up. This is a slope triangle. It may not be laid out on an XY axis, but it's a slope triangle. This is rise. This is run. It doesn't matter how it's like positioned. So they realize that. They also talk about the triangle angle sum theorem. It's stuff that we've all already done. So why do we care about this? Well, not all numbers are nice. Right? A lot of numbers
9.4.
kind of suck. So
Like the
when we have
one-
values like this, right, 9.434. So according to the triangle at right, what is the slope for 32 degrees? Well, the slope ratio, we look here, even though it's not laid flat like a slope triangle, what's the slope ratio for 32 degrees? Yeah, 5/8, right? Rise over run. All you have to do is lay it so that 32 is flat. Conversely, what's the slope ratio for 58 degrees? Well, 8/5. Right, we just flip it around. Any questions on that? There's been about identifying, no matter how the shape looks, still slope ratio. So if we actually do divisions out, we can get 0.0625 or 1.6 when we divide that rise and run. And that sort of value is actually used. So like when I installed my patio, you have to have a certain slope ratio. I should take pictures of that for you guys because there's a lot of applied mathematics in what we did there. So much so that a friend of mine was over the other night. He knows that I used to install patios. And he was like, so did you do it right? Like, is it good? Are you happy with it? And I pulled out the hose and I sprayed a puddle of water like at the top of the patio. And it just slowly trickled its way down, like exactly following the slope that I gave it. And he's like, all right, good work, man. But seriously, there's a lot of this math out in real situations that you're going to encounter. So let's solve these three missing pieces of information here. And I think we got like one or two more problems, and that's really our class for today. I'm just trying to make sure we understand the tangent ratio. Really, if this was an honors class, we would have gone even more quickly through tangent, but I don't ever want to overload you guys. We're at the end of the quarter, so I figured this would give us a nice little like soft ending. We're moving quickly. We've almost covered, well, we have, by the end of the quarter, quote unquote, we will cover 3 chapters.
Compared to someone who feels like we're not.
Right, it feels like we're
really
crawling. I still need you guys, at some point, maybe I can make this one of like somebody's Discovery Day project. I need to do interviews with you because we want to make a little video about Math 1 and like what to expect. So little snippets of like, yeah, I went to the library and worked like 2 hours every day. Or things like whatever you did, just your
Flow
feedback.
charts, I hate them.
Flow charts are the devil.
Yes.
That is not the sort of video we're trying to use.
So I can't say flowcharts otherwise?
I mean, you could say 2-column proofs are
Just
great.
say, get ready for flowchart. 2-column proofs are so much better than flowcharts.
So in A, if we look at it as rise run, the unknown will be on the top. So that works well for us. Set up tangent of 38 equals x over 8. If I do rise run, I'd rather find out this
The
angle.
other angle is 17.
Yeah,
then
17, and then that works more
And
easily.
then x equals 2.75.
So this is one of those things that last year I didn't necessarily teach as make the unknown go on top. But I realized
So
if we
much
just take a moment to find out the other angle, our math is a whole lot easier. And it's easier to type into your calculator.
Yes.
Less buttons to click. So literally, if we're just trying to make our life easier, any technique we can, put those unknowns on top. And then in C, yeah, rise run works all right here. What are you owing?
The answer is C.
Because we don't need to do
Yeah.
any math.
Because
We know
it's 14.
it's 14. What type of triangle?
It's
Isosceles.
Ooh.
Which actually does make it a special right triangle.
A special.
What is x in A? Should be less than 8, right?
6.5.
6.25.
And then 2.75.
Ooh, in unison. Makes my heart warm.
Why?
So, we're done with 3, 2, 4. Right? That was that lesson. Because we overtaught it. Right? You guys are further beyond than what the textbook expects. Good work.
Because you overteach.
So, but there's no point not to.
Wait,
So, we're going to New York. What?
I think we already went to
Move my
New
stapler. Well, okay, yes, but we're going to New York. I didn't go with you. Lindsay, now Lindy, I don't really know who names their kid Lindy these days, but Lindy is kind of like Mrs. Coleman. You didn't know this, which you may or may not know. She has this like condition where she gets nosebleeds, and there are certain people that literally can tell you if I go above a certain elevation, I will get a nosebleed. Like, which is horrible. Like, I feel like that would be terrible.
Yeah.
But so she is debating going up into the statue, right? She's like, I know I get nosebleeds above 300 feet, and because all the statue workers here today are pretty lame workers, nobody can tell her how tall the statue is, right? All the cell phones are dead. We can't Google it.
Wow.
Now the cell phones are dead, but our calculator in our bag does work.
Wow.
And not only do we have working calculators, but we have a working clinometer.
Oh boy.
Now, you're lucky that I'm nicer this year than I was, because last year I had the kids make one, and then I told them that I owned these. A clinometer.
What is that?
Exactly like what you would think. It's a gun that shoots out angles. No, if I am looking at an object, and I want to point to the top of it, and I hold the trigger, and then I let it go, it will tell me the angle of incline.
Wait, can I try that?
So we are going to, when we come back from, I have more. When we come back from Discovery Day break, we're going to use these clinometers to measure objects outside. But if, you guys have like 4. What? Yeah, always, man. My stuff is your stuff. So check it out, see how these things work.
That's cool.
So not only do they still have a charged up calculator, but they also have a clinometer that they brought with them because they figured that they would need to measure some angles.
Wow.
And really, they just they're fun. So they're able to determine that the angle up to the torch is 82 degrees. Her eyes are 5 feet above the ground, like so the clinometer, right, is 5 feet up above the ground.
Why don't you just lay on the ground?
It's because it's annoying, trust me. They did it last year, my students got mad at me. Because I had them doing that, and I was like, we could just do the math and then add 5. And they're like, oh, well, you suck.
But it'd be fun to land.
Well, you can if you want, but then okay, then put the 5 back out. I don't care. So if we try to draw this, let's take a moment, and because it'll be fun, draw the Statue of Liberty in your notes real fast. What do you mean, why?
Oh, boy.
What?
Can I just put my paper?
Like, draw the model.
Wait, can you go up so I can actually look at it and get it to like looks like not?
Reminds me of Stickly.
Boy.
Big hand.
That's the torch.
Yeah.
Give the statue its robe. So now the only reason we did that, really no reason.
Because you have time to waste. And you can see how badly I can.
We are 5 feet above the ground.
It's like okay, but like
We are 5 feet above the ground. The angle, not drawn to scale obviously, is 82 degrees. And the distance to the base of the tower is 42.
Okay, so you want us to know how tall the tower is?
We want to figure out how
Okay.
tall, because you can go up in the torch. When they have the tower completely open,
Why couldn't we go?
they had it closed for renovations. When they have the tower completely open, you can either go up into the observation deck in the head, and you can see out. There's like a band of windows around there, or you can go all the way up to the torch. Now, the other reason we would never take you up there, you climb a ladder
Oh.
on the outside of the statue.
Uh-oh.
So you have to sign a waiver before you go up that says, hey, when you fall, you don't sue us. I actually don't know if they are going to open the statue ever again. Like, to go up to the torch. You climb up inside to get to the observation deck in the head. But yeah, they've had the torch shut for a while. I think.
I was just talking about the.
Yeah, it's expensive. That's the other thing. Yeah, to go inside the statue is expensive. So we have the unknown rise, which we like. So we can set up tangent of 82. I really should send my sister a screenshot of my beautiful statue.
You should. I know what it is, I think.
Height
Oh, wait.
over 42. Now the real problem is, being that you've been to the Statue of Liberty, you know the area around it is not flat. But we will assume that we are somehow flat ground.
She should be fine because I think it's 298.8.
Wait, don't count.
That's what the 42 times tangent 82 got?
Yes.
200, what'd you say?
298.84.
8.5 because it's 8.45, so it'd be 8.5.
So she just
But you know.
So you can put
So she
845.
She jumped up.
But then it's a 5 after. So
Five.
You stuck in the school.
Oh,
No.
You need to add. Oh yeah, you need to add the 5 feet. So
I was gonna wait until like somebody realized. I was just gonna sit here. Just swing my feet.
So that's where you would.
The 5 over there. You're right. Right.
So she
This.
can't go all the way up.
This is 298. But we are 5 feet above the ground making that triangle. So when we add that 5,
Told you she should have laid
we're at 303.85. So maybe if she climbs up the tower, it just stays like down like this. Right?
I don't know. But I mean, like,
Would
what
it
it
work
was it
that
really
way?
that bad getting in
I don't know. Do you want to bleed all over the Statue of Liberty? Hey, that's up to you. You leave your mark. Alright, so we will put away the clinometers for now because we will use them when we come back from break.
Okay. Do
Or
we have
short,
anything else
quick
to
little
do, or
break.
can we work on homework?
That's it. So honestly, that's why I said do 6 or more of those problems. Do whatever you want to do to practice these skills. Excuse me. I would encourage you, pick the homework problems that involve Trig. and do a little bit of that practice. But if
I'll
you
just
are
pick some
feeling,
random ones.
if you're feeling crazy comfortable with the
You know what I
animation,
can do? I can roll some dice and see what the probability is of getting each one and figure out what you want to do based on the probability of the dice. Because, you know, math.
because man, I don't know. If you
And I'm going to work on my homework from yesterday because
I already did my homework.
Look at that. 20 minutes. I told you it wouldn't even take us a half hour. Actually, did I say 20? Maybe I said 20 minutes. Either way,
you said it wouldn't go over 30 minutes.
well, I made the goal by 10 minutes, so there you go.